All right, so welcome back. This is week 2 of ECE in 1940. You had your first lab on Friday, and most people got that in. There's some people still with account problems. Don't worry, we'll sort those out still. I did look at a lot of the submissions for Hack 2, which is actually due tomorrow at midnight. And in more than one case, I saw that the repos were not made public, so you need to make sure that those are public repos, otherwise we can't grade them. If they're not public, we can't see them at all. So to keep that in mind, you'll have your next lab, Lab 2, and your Hack 2 this Friday. It's going to be covering the basics that we'll finish up sometime this week. Remember that we are online, so if you've got any questions, post to Piazza or to the YouTube live stream. There is a question in here, though. Was there a question? No? Yeah, go ahead.
He asked if you meant Hack 1 instead of Hack 2.
Hack 1 is due on Tuesday. Okay. Right. Hack 2 is this Friday. I mean, you start it this Friday, and then all hacks you start. The lab is due on Fridays. The hack that you start on Fridays is always due the next Tuesday. Right. Okay. All right. So to remind ourselves of what we did last time, we went through some of the basics of C so far. And we did so in motivating by creating this conversion program that converted pounds to kilograms, or kilograms to pounds, excuse me. And we went through the basics of commenting, documentation, things like that. Doc-style comments are what you want to get into. You want to get into that habit. Preprocessor directives that allowed you to bring in external libraries to define these macros that are basically copy, replace, kind of identifiers, for example, pi. Then we talked about the main function and the basic structures of a program and how much it's very much like writing an outline to an English paper. You use the same indentation. You have one sentence, one directive per line that's ended in English. It's ended by a period, but in C it's ended by a semicolon, and a bunch of other things like paragraphs for form code blocks, etc. We also talked about basic input and output using scanf and printf. Again, if you use these placeholders, depending on the variable names that you want to use, or variable types that you want to use. For integers, it's %d. For doubles, to read in a double, in other words, from scanf, you use %lf for a long floating point number. For printing, you just have to use %f. And for reading in a single character, %c, although that's far less common. Or printing a single character. We talked about basic variables. The naming conventions that you'll probably want to follow are going to be lower camel casing convention. If you want to, you can go ahead and go with lower underscore convention, but again, you're going to ruin your pinky doing that, and it's eventually going to fall off. Variable names should be good variable names, descriptive, right? Short, eschewing abbreviations, or you're not paying by the character, so write them out. Don't have just the terrible placeholder names like foo or variable 1, variable 2, variable 3, etc. We went through the 3 basic types on integer for whole numbers, but there is a limitation on that, both negative and positive. Doubles, and again, there is a limitation on that. There's 14 to 17 decimals of accuracy somewhere in there. Right? Characters are a single character value according to the ASCII text table, in which case all uppercase letters appear before all lowercase letters, and then you have numbers and punctuation and other characters. Everything has an integer value. So in C, actually, a character is an integer. All you have to do is look up the integer value in the ASCII text table, and that's the integer value. Right? All right? So we are good online. We left it off with talking about the basic operators, including assignment, the basic arithmetic operations, plus, minus, division, and multiplication. And we also noted the PEMDAS rules. Everything that you know about PEMDAS, right, parentheses, exponents, multiplication, division, addition, and subtraction, those rules are the same in coding. If you need to elevate an expression like a plus b and do that before times c, then you need to put parentheses around it. Okay? The assignment operator is the single equal sign. It takes whatever's on the right-hand side and puts it into the variable in the left-hand side. So consequently, let's go ahead and go over here to the demo. If you declare an integer variable, say int x, what value does that have right now? What's stored in that variable? nil, 0, nothing, dead beef, right? 99 times out of 100, yes. It could be the garbage value that was whatever was in the memory, stored in that memory location before. So there, C defines no default value. Anything could be in an uninitialized variable. So initialize it, right? Set x to the value 10. How do I do that? X is simply equal to 10, right? It's that assignment operation. If I've got other values, for example, if I've got A, B, and C, int A is equal to 5, B is equal to 3, C is equal to 10, right? If you've got multiple variables of the same type, you can put them on the same line with commas, and you can also optionally assign them values. So if I've got those values, I can reset x equal to A plus B times C, right? And that's not the same thing as A plus B times C without parentheses. The B times C would end up getting evaluated first, right? Not the same as x is equal to A plus B times C, right? So be careful. Note that you can also set it equal to another variable value. So if I say set the value of x to whatever is stored in C, then I can say x is equal to C. That is not an assertion that x and C are equal, right? An assertion like that would need to have some sort of like equals equals. We're checking for equality. We'll talk about that later when we get to conditionals. But you can take the right-hand side can be an expression. It can be what's called a literal. In this case, this is a literal. It's literally 10, right? It's just a fixed value, and it puts it into that variable. It can be an expression, right? It can be a single variable, right? It can also be more complex expressions. For example, what if I wanted the root of some quadratic equation? So what's the quadratic equation? Remind me. Negative b plus minus, okay, square root. Did you see that on your keyboard? SQRT, good. So we need to bring in a math library, right? And where do we do that? We can bring it up here. Include math.h. SQRT, sine, cosine, tangent, arctangent, right? Whatever you see on your scientific calculator, those functions are going to be in the math library, right? So if I require the square root function, I can bring in if this requires the math library. Right? So what am I taking the square root of? Is it b squared? B squared minus 4ac. Is that right? Okay, divided by 2a. All right. So there's lots of syntax errors here. Is this going to even compile? Nope. CCC Demo, right? So lots of errors here, right? It doesn't know what to do with 4ac. It doesn't know what to do with the 2a. It also doesn't really know what to do with this, but this is syntactically correct. What is it doing? It's saying plus and then subtraction, which is subtraction, right? It's not even going to complain about that, right? But is that going to get me two roots, the plus root and the minus root? Nope. You can't do something like that. If you want two values, what do you need? Two variables, exactly. So I'll go ahead and say that this is the minus root, and then I'll think about the other root later. The next problem, of course, is 4ac. Is that proper multiplication? Multiplication is done with a asterisk. So I need star A star C. Likewise with this. Still two problems here. Right? Am I going to get what I want out of this? Good. Okay, that's one error. So what is this? This is called the caret. Some languages support this. Other languages allow you to do exponentiation, x raised to the y, using star star. C supports neither one of these. Right? So what is the best way of getting b squared? B times b, exactly. Another alternate way, if you're not always going to just raise it to the power 2, guess what? The math library gives you this pow function, raising x to the power y. Right? Those are arbitrary numbers. So if I want 3.14159 raised to 2.71, you can do that with the POW function. Right? In fact, that's probably what you'd have to do, unless you want to roll your own numerical interpolation algorithms. Right? Nope. We're just going to, but which is simpler? Calling a math library function to do some sophisticated mathematics behind the scene, or just simply b times b. B times b. Right? Simpler code is generally better code. And by the way, this was compiling and not complaining, because this does have a meaning in C. If you get into bit twiddling, right, where you are doing bit masking and stuff like that, this is the bitwise exclusive OR operator, if you know anything about that. If you don't, forget it. It's not important to this course. But if you want to do some bit twiddling where you're screwing around with the individual bits of a byte, right, then you need to get into that kind of stuff. Left shift, right shift, masking, and hexadecimal numbers, all that stuff. Right? All right, there's still one problem here.
The whole top side of the bracket.
This whole, yeah, what's the thing on top called? The numerator, and the thing down below is the denominator. And if I want those grouped together, I need to do something like this. Not only that, but I need to do it on the denominator too. Why? Without that, what would happen? It's just divide by 2 times a, so a ends up in the numerator. There we go. All right, let's print this out, see what happens. Printf, x is equal to, well, it's an integer, right? So let's go ahead and print it out as an integer. Does anybody know what the, what the roots are of 5, 3, and 10 off the top of their head? Oops. So here's a trick. If you ever get this message of undefined reference to square root, hey, I included the math library up here. Some compilers can, and configurations of compilers can be persnickety. You need to link in that external library. Now, for the vast majority of libraries in the C, that are standard to C, you don't need to do anything. The compiler will take care of it for you. But it's this one time, this one math library for historic reasons. If you're interested, I can send you the CFAQ on it of why it is like this. But for this one instance, you might have to use -lm to get it to compile. -l stands for link in, m stands for the math library. Link in the math library for me. Now, in some compilers, some configurations, you don't have to worry about this. But if you're using the CS50 IDE, apparently you do. Right? At one point, I thought that wasn't the case, but whatever. All right, let's run it. What are you expecting? Anybody pulled out their calculators and did the roots of that for me? Okay. Does that look right? That looks really weird, right? All right, so what's going on here? Well, let's look at a simpler example. Let me go ahead and reset some values. A is equal to 10, B is equal to 20, okay? Now, let's go ahead and set C equal to A divided by B, okay? And then let's print that out. Printf, C is equal to %D and the line, C. What is 10 divided by 20? 1/2, right? Not in the C world, right? What's going on here is these things are integers. Remember, I declared them as integers. An integer divided by an integer has to be an integer, especially if you're going to put it into an integer, right? If you've got a box that only holds whole numbers, right, you can only fit the whole number part into that box. Right? So what A divided by B is 0.5. Okay, what happens? 0 is the whole part, 0.5 is the floating point part. It gets chopped off and thrown away. That's called truncation. Right? The floating point part gets cut off and thrown away. This is known as truncation. Right? All right, fine. So I can't use C. Right? I need an actual double to hold that value, double. So I'll go ahead and declare Y here, and I'll set it equal to A divided by B. And I will change my placeholder here. %D is an integer, right? What's the placeholder for a floating point number? F. Okay. Run this again. Oh, it's even complaining about this. percent f c, oh, sorry, I shouldn't be c, it's y. That's why it's complaining. It wasn't complaining before because it was integer, integer that matched. Now it's not complaining anymore. By the way, that was a warning. C will issue warnings and errors. Errors are syntax errors. It didn't compile for whatever reason. Warnings are simply, did you really mean to do that? If you really meant to do that, okay, fine, we'll go ahead and go with it. But you probably want to take another closer look at that thing, right? So let's find out if this fixed our problem. If I run it again, it's still 0, but now it's 0.0000. The result of the operation itself is also in an integer. So what I need to do is I need to convert one of these things temporarily to a double, right? To get this to work, you need to typecast the at least one of the operands. So if we've got an operator like plus, A plus B, plus is the operator. The two things that it's operating on are called operands, all right? And then in this case, A and B are the operands. So I need to convert one of them temporarily, double, A divided by B, right? This is true of most statically typed languages, C, C++, Java, etc. Most of them will require you to either typecast to get this kind of behavior or something like that. That's not true of many dynamically typed programming languages. For example, JavaScript, PHP, Python. You can go ahead and go A divided by B without a care in the world as long as they're both numbers, right? And it will automatically convert it to whatever type it needs to be for the correct result. In this case, you have to use an explicit typecast. What I'm doing is I'm saying, for the purposes of this division, simply just take A, convert it to 10.5, or 10.0, excuse me, and then divide by 20, giving me a result of 0.5, and now I can put that into a floating point number. So if we run this again after we compile it, now I get 0.5. Right? I didn't change the type of A here, by the way. Oops. A is still, and always has been, and always will be, an integer. You can't change it. But down here, you can temporarily change it for the purposes of that operation. Right? It's still going to be an integer at this point. A and B are still integers at this point. Okay? That's typecasting. Be careful. Other pitfalls. Right? Overflow. So what was that number before? The maximum number right there, 2.147 billion. Let me go ahead and 2147. Where is that? There we go. So let's come over here and set x to be 2.147 billion and change. That's the maximum value that it can represent. And I've already declared x here, so I'll go ahead and reuse it. You can't declare it twice, right? You can't say there's a variable called x, and then later on, there's also another variable called x, right? You can't have two variables in the same scope with the same name. So instead of redeclaring it, I will simply just reset it, right? You can always do that. Up here, x had a value of 10. Then I changed its value. And down here, I'm changing it again. It wouldn't be a variable if you couldn't vary its value, right? So it will change to whatever you, throughout the life cycle of your program, it'll change depending on the value that you set it to, that you use the assignment operator on. So let's print this out. X is equal to %d and the line, x. And then let's add one more. X is equal to x plus 1. There's an assignment operator, but it uses x on both sides. Remember, the right-hand side, it's not an assertion, it's like an algebra. If you were to go to your algebra professor and say, or calc professor and say, by the way, x is equal to x plus 1, right? No, that's nonsense. What it's doing is it's saying, take the value on the right-hand side, which is whatever is stored in x, which is 2.147 billion and change, add 1 to it, and then take that result and put it back into the variable x. Okay? What value will it have now? 0? Is it going to have 2.147 billion ... 48? It should if it were mathematically correct, but it, well, oh, yeah, 48, except what's happened? It's wrapped around, right? So don't think of numbers in a computer like you think of numbers on a number line. Here's a 0 in the middle, and then it extends off to infinity in the negative direction. It extends off to infinity in the positive direction. It's not an infinite line. It's a circle, right? So if you add, and get up to the maximum value of 2.147 billion, what happens is overflow. Just if I have 999 and I add one more, what happens? If I have 999 plus 1 is 1,000. You've overflowed to the next decimal point. What happens in the machine is that you've overflowed that bit into the sign bit. And that's the consequence. It wraps around and becomes negative. If I keep adding to it, then, I don't know, let's find out what happens here. Print it out each and every single time. Well, now it's going to work. Why? You're just adding something to negative. In other words, this circle, you've gone around to the maximum value. What are you going to do? You drop down to the negative, the least value down here, and then you're working your way back up the other way. Right? It's overflow. You can also have underflow, right? If you take that negative maximum value, 8, there we go, and instead of adding 1, you subtracted 1, what would happen? Something like that. Let's find out. So I've gone too far negative. And so it wraps around back up, right? Again, think of it as a circle. You get to a maximum point, it drops you somewhere else, right? And you get results that don't make any sense. So understand the limitations, that you only have this so much that you can represent positive, so much that you can represent negative. With a double even, you can represent very much larger numbers, just only 17 digits of accuracy out in the front. Everything else will be garbage. Right? That's a computer for you. It's a finite object. We don't have infinite computers sitting down the hall, right? We just have larger and larger computers. And you can do that, right? If you need more bits, if you need more significant figures, you can have that. You just need to allocate more memory for it, meaning that you're going to be bringing in what's called a multi-precision library to deal with those arbitrarily large numbers or arbitrary precision numbers, okay? Then everything is done in software and it's way slower. You pay a price for that. Right? So overflow and underflow. Right? Okay, let's see. Other operators. So they're operators, placeholders. There's the program that I wanted from before. And by the way, let's go back to that program and finish it off by getting rid of the cruft. So did I talk about cruft before? Right? The cruft haul, you fill it up with garbage. Cruft is stuff that should not be there. 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 And that should not be there. You don't have to double space, but each one of these is individual enough that double spacing is fine in this case. If you certainly should not do something like this, probably, right? In fact, you should definitely not do something like this. Oh, I don't need any white space at all here. I'm going to go ahead and put everything on one big giant line, right? Is that a readable program? Oh yeah. It runs, and a number of kilograms, 10 kilograms, I get the same thing, right? But now remember that there was a problem here, right? Percent F, and this is, okay, we'll fix the problem after we can actually read it again. So if you ever get a program into this kind of, terrible styling, don't worry. Go through and manually fix it, or better yet, use a tool. So there's this tool that's available in the CS50 IDE and available in most Linux distributions called A-Style. A-Style, what does A-Style stand for? I forget. Man is the manual page. I'm looking up the manual page on A-Style. Was it multi-line? Why are you called A-Style? What is the A? Artistic style. There we go. Did you see that? It's an artistic style. A-Style demo.cs.c. Right? Oops. Really? You're going to unchange. You're not going to change that. Okay. It must really like this style or something. I've never seen it refuse to do anything before. Unchanged. Okay. It's happy with this, apparently, yes. Let's get everything on the same line. I've never seen this before. Formatter, beautifier, written in C++. It handles the following programming languages: C, Objective-C, Java, blah, blah, blah. All right, it's not giving me anything else here. So, online code beautifier. These things are called beautifiers. Yeah, go ahead. Do you have a solution? Oh, thank you. I had great style already. Yeah. Over here, demo is what he's talking about. I had great style. It's that's beautiful. That's great already. A style. Thank you. Convert. There we go. There. Now it formatted. Let's see what it looks like and the reveal. Well, in this case, it just indented everything. Vertical white space. It's not going to do much. But if I take this over to, say, an online code beautifier, right? Find C source. Nope. There's one that I linked to directly on the on Canvas, codebeautify.org. There we go. All right, where's beautify? Do I have to hit beautify, or is it did it do it automatically? Oh, error. Maybe I have to select a language. C, C++, new. Oh well. Your mileage may vary. Find one online that looks good. It looks like it might have done it automatically. I'm not sure. But it didn't change it because this is what A style would do. They're called beautifiers. And by the way, there are the opposite things. They're called uglifiers. If you want to obfuscate code. This is usually done in languages that are not compiled. For example, JavaScript. You write beautiful, nice JavaScript, and then you want it to set it over the network because it's being served on a web page. Well, a network doesn't care about all that white space, but if you're wasting bandwidth sending over all that white space that ultimately gets ignored, that's wasting bandwidth. So you can send it through an uglifier, right? Something that changes all the variable names to as short as possible, something that removes all the unnecessary white space, et cetera, and crunches all this code down so that it's as small as possible so that you're not wasting network resources sending it over the network, right? So there are applications to both of these both ways. In this case, you want nice, clean, beautiful code. And that's nice, clean, beautiful code so far, right? Okay, so there is definitely a link to one in Canvas in the extra resources. I'm going to go ahead and cut and paste this and put it in your notes so that you have it. All right. So more. There we go. Remember, these are pushed out to GitHub at the end of the day. So if you're, go ahead and check them out. They're much prettier on GitHub when they show up. There, that's prettier because I specified what language it was. Okay. So other operators. So you can use the division remainder operator. Right? Percent, it's a percent sign. So for example, if I go, go into code mode here, 10 divided by 2, right? So actually, let's go with something else here first. All right, 10 divided by 3. Now if you go 10 divided by 3, that's going to be 3.33333, ... right? But that's if you use the regular division operator, and truncation takes over. Percent is the division remainder operator. So now go back to grade school where you didn't have floating point numbers. 10 divided by 3, how would you write it? 3 goes into 10 how many times? 3 times. And what's left over? A remainder of 1. So this results in 1, i.e. the remainder. Right? Some more examples. What if I go 10, and another way to read this is mod, right? Mod 2. Why mod? Have you looked at moduli yet? Right? So that's like the math functions, right? If I go into math mode here, 10 mod 2, or something like this, or p mod. Maybe something that looks like that, right? If you haven't seen it yet, that's fine. It doesn't matter. It's just modular arithmetic. It's remainder arithmetic. 10 divided by 2, what's the remainder? 0. What about, okay, YouTube is stabilizing. Come on. Oh, okay. 10 mod, I don't know, what's another example? 5. Results in, again, 0, a remainder of 0. Let's see. 11 mod 2 results in 1, the remainder, right? So how could you use this, say, with the second example and the third example here? How could you apply those? The remainder tells you whether or not a number is even or odd, right? You could also, these are arbitrary numbers. So 11 mod 3, or divided by 3, what's the result here? 2. It's not always 0 and 1. I just wanted to give you one more example where it was something else. What about one last example here? 11 mod 11. 0, right? You can divide something by itself. What about, and I lied, one last example, 11 mod 10. Mod. Oh, good question. 20. There we go. Results in what? So 20 goes into 11 how many times? 0. So what's your entire remainder? 11. Yep. Good. All right. That's the integer division operator. Let's see. More math stuff. So the math library that is in math.h has several constants, right? So m underscore pi, that naming convention looks kind of familiar. When we did our conversions over here, we defined pounds per kilogram, all uppercase, separating each word by an underscore. M here is simply just appended to indicate that it's the math library's pi. If you want to define a different pi, go ahead, be my guest, right? But this is the math library's pi. You also have, what else? M underscore E, 2.71, et cetera, et cetera. You also have other functions. For example, I mentioned them before, sine, cosine, tangent, square root. Right? What else? Pow. What else would an engineer want? Nobody still uses slide rules, do they? Do they teach you slide rules? That's a good question. I mean, not even I was shown a slide rule. Come on. But what did you use? What did the old timers use slide rules for? Computing the natural log, right? Exp, right? All those things that have these big giant not actuarial tables, but all these big giant lookup tables, and then you need to get some more significant figures, so you pull out your slide rule and you do some linear interpolation methods or whatever, etc. Remember that you may need to compile with the -lm flag at the end, right? In order to link in the math library. Okay? What else is there in the math library? How could you find that out? Documentation. Or RTM. RTM is read the manual, right? So when we say read the manual today, we mean Google C math library, right? If you Google C math library or math.h or something like that, then, well, there 50 different websites will pop up here, but oh, there's huge value. But you've got arc sine, arc cosine, the two argument arc tangent, right? Hyperbolic tangent function, or what is it? It's not calc, it's it's not, where is this stuff introduced? Geometry, is it, trigonometry, there we go. Trigonometry, thank you. Log, natural log. Oh, sorry, I think I misspoke then. It's not ln, it's going to be log. So let me put that back over here. It's not the natural log, it's log. And this is the natural base E log. All right? There we go. So how do you know? Read the manual, etc. Questions so far? No? All right.
How do we know what the defined variables come in as, so doubles or floating or?
You mean for like a library function of some sort? Reading the manual will say it takes a double and returns a double. Right?
Yeah, but the defined
Oh,
variables.
I guess it's not telling you, is it? M pi. Nope, constants. Nope. The tutorials point's not the best website. Geeks for Geeks is not much better. Probably C++.com, even though it's C, that might have better documentation. There we go. Well, it's only, those are macro constants. I don't see m underscore pi. Maybe it's not in the math library. No, I don't know. Let's go ahead and find out by reading the manual over here. Man, I don't think that this is going to pop up in the man pages. Yeah, man, keyword, m pi. Nope, nothing appropriate. Like Unix documentation would contain anything inappropriate. All right, so yeah, those are the only two I know. And you will find that a lot of times you will get stuck in documentation hell, meaning that not everything is standard. Just because there is this cool function that is provided by Ubuntu Linux using this GCC, right? That doesn't mean that it's part of the GNU standard, right? And GNU is not even part of the C standard, right? The ANSI C standard or whatever that we're up to now. And not only that, but you've got C89. You have C70, ANSI C was the original, C89, C99, C11. These are all of these different standards with different things in them. So not everything is going to be interoperable. Don't worry about it, though. Those are the corner cases that, well, oh, okay. It's not working. This is why, because it's not there. Right? Yeah?
Would like statically linking to those standard libraries help there?
Uh,
Or is it not what you can do at that point? It's a feature set on one operating system and not
yeah, if you're going to have to bring in a library, if it's or reconfigure or something like that. A lot of the times, the standard library, I don't even know where it would be. I'd have to go find where the math the compiled math library is on this particular system. You can find it, but it's been compiled already, right? There's not much you can do. You can go back to the original source code and add your own stuff, right? Screw around with it, and then compile it for that particular system. But you're doing something that's really, really non-standard at that point. And why? You could have just written your own library to do it, right? And then brought them together. And then they can live happily off into their own little worlds there. Right?
Will Ireland warn you if you're trying to multiply, let's say, a double by an integer?
Good question. So, if we were trying to do what we were doing before, 10, b is 20. Right? Int c is equal to a divided by b. Right? GCC Demo? No. Now, this is the default. Right? The default is, I'm only going to tell you about what I think are the important things. What you can say is, I don't care what you think what's important. Tell me everything. And we'll demonstrate this later on when we talk about linters. But GCC Demo WAL. That's not a wall. That's warnings. Tell me about all of them. Right? And even in this case, I don't think that it's going to. Oh, it did. Oh, but it's a different warning. It said, it's an unused variable. C, you created a variable. You didn't do with it anything with it after that. Why did you do that? Maybe you want to go back and pick off that lint. We call that lint. It's kind of like cruft, but it's lint. Your clothes are clean. They just came out of the dryer, but You've got little pieces of lint on them that you need to take off and with a lint roller. And turning on all the warnings is a way to identify some of that lint there. But it's not going to identify everything. A divided by B, well, that's on you. You should have known that C did this. Now in a programming language like Java, this would be a compiler error. Definitely. Java compiler would not allow you to do something like this.
What would your printf function look like if you were printing in_pi or in_e?
%f, because it is a floating point number, m sub pi. Let's find out. All right, it compiled only warnings. 3.14159. Is that correct? Anybody know lots of digits of pi? Is that right? 9, 6? Okay. So let's go ahead and get more sig figs. I want 20 significant figures. Let's go ahead and run that again. 8 out. Getting more, right? Now, that's all 20? Okay. Wolfram Alpha, let's ask. Tell me about pi. Oops. There we go. So I will cut and paste that. And that's not a command, I know that. 5, 9, 2, 6, 5, 3, 5. There we go. I think it differs right here. Right? Oh. Oh, is that?
When it hits double 1,
All
I
right.
think that's wrong.
Online get diff. Oh, come on. I wanted an online get diff. There we go, diff checker. All right. Touch pi1.txt, touch pi2.txt. Pi1 will be that pi, which I believe is from the from Wolfram Alpha, and then pi2 will be our pi from the C standard library. And by the way, I definitely know it's wrong because 0, 0 right there, that smells fishy. So 3.14159, get diff pi1 and pi2. Get some more room here. Come on. There we go. So it ends right there. So how many digits did we get accurate? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Like I said, 14 to 16, 17 digits of accuracy depending on how lucky you are. Right? After that, it gets inaccurate. Right? So let's go back over here and talk about what I just did. This is called a modifier. Okay? A modifier is something that you can modify printf and give it some more specifics. So let's go ahead and print out pi by default. So by default, all floating point numbers are printed with 6 digits of 6 decimals, I should say, of accuracy. Right? So if I just go %f, 6 significant figures, and they get rounded, and are rounded. Right? That's why I was asking, is it 1, 2, 3, 4, 5, 6? And then it became 3, right? Let's try that again. CCC Demo. See, it became, oh, here, sorry. Let's end the lines so that it is readable for us. See, it got rounded to the nearest figure. Did that change pi? No, pi was built in, right? It's not even changeable because it's declared as a macro. Printing does not change whatever you're trying to print. But for the purposes of printing, if you only want 6 decimals of accuracy, what does it do at the end? It automatically rounds for you. If you don't want it to round like that, what's the solution? Rounding manually. Double 10.5. int rounded is equal to, we're rounding, that sounds like an operation that deals with numbers and math. So therefore, in the math library, we have a round function. If you want to round, oh, I need a variable here, sorry. If you want to round x, you can do that. Printf x is equal to %d and the line, or rounded, sorry, rounded. We're not changing x, and we have to link in the math library. Right? It went from 10.5 up to 11. If it was 10.25, what would happen? It would round down to 10. Right? If it was 10.99, it would round up to 11. Good, right? Etc. Now, what if I wanted to go ahead and round to the nearest, say, 10th, or to the nearest 100th, or something like that? Here's a trick. Round to the nearest 100th. So for example, I'll say I've got $10, 25 and a half cents. I'm going to round that transaction up to $10.26. Right? I want 10.255 to be rounded to 10.25. Ideas?
Multiply by 10,
Multiply by, okay, so if it's the tenths, yes. If it's the hundredths, though?
or, yeah, 100, sorry.
100. So x times 100. What will that do? That will float the decimal point over so that it doesn't look like 10.255. It looks like 1025.5. Now, call the round function. That will round it to 1026. So is rounding 10.255, rounding that to the nearest hundredth, is that 1026? Nope. So what should I do with the result? Divide by 100. Restore this to 10.255, and let's print out, and then we need to capture this. Double y is equal to this rounded, and I'll steal that, copy pasta, y, and y. Oops. Now this should be f. Thank you. That's a warning. Your mileage may vary. That's probably not a standard warning. So if you, in another compiler, it might have been just completely silent about that. Right? GCC, run it again, and get that out. There. I got it to $10.26, like I wanted. Oops, I should have written 26 cents there. Right. What if I wanted it to the nearest tenth? Instead of multiplying by 100 and divided by 100, multiply by 10, divide by 10. What if I wanted to round to the nearest 1,000 place on the other side?
Divide by 1,000 first.
Yeah, or multiply by, divide by 1,000, good, to get it down, then round, so you're just in the opposite. Or another way of saying that is multiply by 1 over 1,000, or e to the -3 or something like that. Right? Okay, there's a trick. Let's come back up here and finish this now. What this one does is this specifies that 20 decimals of accuracy be printed. Right? What if I'm doing less? What if you want less? If I'm printing, for example, money, right? Pi is not money, but let's treat it as money, $3.14. If I only want 2 decimals of accuracy, it would be 0.2f and the line.
What's the dollar?
That's if I was treating it as money.
Oh,
Sorry, that should be percentage there. So $sign is just a $sign. If you don't want to treat your pi like money, then you can do it like this, right? But if you were to print out, say, currency, like you will be doing eventually, then yeah, you need to put that $sign in front of it, right? Only 2 decimals of accuracy. You can also have another. You can also pad out leading space. So what I'm going to do here is use a combination. Percent per 2, let's go with 10.2f end line, m sub pi. What this does is this prints at least 10 columns with 2 decimals of accuracy. Right? So in contrast to this, right, it just printed out 3.14. That's 4 columns. If I'm saying I want at least 10 columns, then how many remain? 6 columns over here. Right? 4 for the 3, and the period is counting as a column. 1, 4, there's my 4 columns, but then I can pad that out with spaces, 6 spaces here is what it's going to end up doing. Right? 1, 2, 3, 4, 5, 6. All right? Now, why would you want to do something like that? If you want to align everything in printing, as in like a ledger book, all of the periods line up. It doesn't matter how many significant figures you have out here. It doesn't matter how big your numbers are out here. All the periods would end up lining up. And you can use a trick like this. You can also use it for integers. You can use it for integers. So int, my UID, say, is 1, 2, 3, 4, right? Printf, percent 8f, or d, sorry, end the line. And I'll say that my NUID is equal to this. NUID, there we go. What will that look like? My NUID, and then I had a space there already, so 1, 2, 3, 4, because I'm saying print at least 8 columns. If your NUID is only 4 digits, well then, 4 digits over here, then that's going to pad it out with a bunch of spaces. If you don't want it like that, you can do another thing. Right? You can pad out with zeros instead. So same thing. Oh, no, that's not what I want. Sorry. Move it down here. You can pad out with zeros instead by putting a 0 in front of it. What will that do now? It'll print out 8 columns, but it'll pad it out with 4 zeros in front. We don't write numbers like that, do we? Right? But an NUID or a social security number or something else that looks like a number, right? Those sometimes we do write leading zeros. Right? How many people's NUID starts with a 0? It should be at least 10% of you. 1, 2, should be 4 of you or so, right? No? Okay. How many have a double 0? No? Okay. That would be only 1/100th of all the student body. Right? They are assigned uniformly at random, so there's got to be some out there. There's got to be one person with 8 zeros. That's probably a reserved at that point, though. Okay? So that's formatting, and that's why we call it printf, because you can use all these formatting tricks to get a lot of stuff done. Right? So formatting demo. All right? Okay. Any questions so far? No? All right. We go to 45. So the last thing that we'll do today is talk about interactive input. Right? So interactive input. With with some programs, or some programs I should say, some programs expect a human user, right? You can, using scanf, we prompted the user for input, all right? However, most programs are not interactive. They don't expect a person sitting there mashing the keyboard, right? Now, what people perceive as computing is consumer-driven, right? I don't have my phone here. No, here it is, right? This is what most people think of as programs. Human-computer interaction. They think of input as hitting a bunch of, or clicking a bunch of buttons with their fingers, or hitting a keyboard and typing in input and stuff like that. But the truth is, the vast majority of software is for automation. No human is sitting at a computer thinking or entering input or something like that. That's the whole reason that we write programs, is to automate stuff, right? We don't want a human sitting there having to type input and get an output. The vast majority of programs are not meant for human-computer interaction. So one way of getting rid of this interactivity is by piping in input automatically. So programs can be written to take input non-interactively through the use of command line arguments, or CLAs. Right? Command line arguments, command line interface. This allows you to do some really powerful stuff from the command line. For example, let's see, I don't know, ls or more etc password. Now in a real system, these would actually be users, okay? Lots of users there. I'm looking for one in particular. I can pipe that in through a grep command that I'm looking for anybody who has an R in their name, right? There. Or that's going to end up being anywhere on the line. But anybody who has an R in their username or something like that. I can further grep through that. Oh, okay, well, I'm looking for somebody whose user ID has a 1 in it. Pipe that into another 1, right? And I get all that stuff. I'm winnowing it down. Okay, well, that's good. I found most of those. I can pipe that into, say, a sort, right? And guess what? It sorts it for me, right? You can only do this if you've got an input-output piping system. You've got input on one end, and then you can pipe that output to another program that takes input non-interactively, automatically, and then pipe that into another program and pipe that into another program. That's why we call these things pipes. Right? These vertical lines, sometimes in math they're called Sheffer strokes. In computer science we call them pipes. Why? Because they pipe stuff. They pipe command into command into command. Right? And if you are working at the command line like this a lot, you will be way more productive than somebody that sits there and has to click, 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 click 50 times to do one thing. Right? Again, we like automation. We like zippering programs together, piping programs together to get more and more functionality. Right? So how do we do that in our own programs? I'm going to show you how to do that with our conversion program here first. I'm going to reclaim some real estate here. And I do want to keep the old version here, so I'm going to copy CP, convert into another convert CLA.c. Okay? I'm copying that one file into another file. You see that this file pops up over here. Right? It's just a copy. I'm going to modify this copy to, instead of interacting with the user and prompting for input, I'm going to read the input from the command line arguments. That's where these things come in, argc and argv. So let's explain that before we go on here. Right? Let's see. All right, so CLAs are provided to a program when you invoke that program from the command line. So for example, if I go a.out, A, B, C, 10, 20, 30, the above example has 7 command line arguments. Right? Let's go through them. argv sub 0 is the first and is always the executable file name. Why? Because your file name could be a.out. It could be my really awesome program.exe. It could be this less awesome program.bat or something like that. Whatever you name your file, if you need access to that name, it's provided as the command line argument, the first one. Right? That's the one that we're going to probably ignore for now because we're not dealing with strings yet. argv sub 1 is the first user provided argument. Right? In this case, A. Right? argv sub 2 is what? In this case, B, etc. And I'm not going to go through the rest, but let's note what the last one is. argv sub, what's the last one going to be if I started at 0? And there's 7 of them. 6 is 30. Right? All of these arguments, however, are strings. Not necessarily numbers, right? So to convert an argument to a string, you can use one of the following. A to I converts an alpha numeric string to an integer. There we go. And, well, if A to I converts an alphanumeric string to an integer, what would I want if I want to double a floating point number? A floating point number. A to F, right? Converts, it's not D, A to D, because just because that's what print, it's kind of like printf. %D is for digits. %F is for floating point numbers. Converts an alpha numeric string to a double. Right? There is no conversion of a character, or we won't have need to do that, but you can do it, but you won't need it. So we'll skip it. All right. Also, the first argc holds the value, tells you, let's go with this, tells you how many arguments were provided. All right? So you can do some basic error checking here, but we will need some conditionals later on. I'll go ahead and preview it today, though. Right? So let's come back over here, and now I'm not reading any input. Instead, I'm going to be expecting them to run this conversion program from the command line, giving me, say, 10.5. Right? 10.5 would be the number of, before I was asking for how many kilograms, well, 10.5. Okay, fine. Right? And then run it. Right? Except that that's not the same program. So what we're going to do is we're going to take this first argument and convert it. Kilograms, instead of calling scanf, which prompts for input and then sits there and waits for them to mash their keyboard and hit enter, we're not even going to prompt them. We're just going to simply take it from the command line. Kilograms is equal to, now, if we are going to support kilograms as a floating point number, say 10.5, what do we need to do to our integers over here? Change it to a double. Right? And if I'm converting the first argument to a double, it's going to be A to F of argv sub 1. Right? So again, what is this doing? It's converting the first user-provided argument to a double. Right? What about the second user-provided argument? Do we care? I'm just asking for one input here, right? So that's all I need. Yeah?
So those, when you declare main, is argc and argv, is that what you have to call them, or is that just standard?
Let's find out. That's the usual. Let's find out. Convert CLA. All right, there's other warnings here, but it was happy with it. Weird but true. You could probably call it X and Y. Don't. argc, argv. Argument count and argument vector. Argc, argument count, and argv, argument vector. What is a vector? Math folks, is it just one value though? 2, 3, 4. It's dimensionality, right? An n-dimensional vector is going to have n values in it. It's just a list, right? This is a list of arguments, a list of strings. Okay? Now let's fix what it's complaining about here. That's however many pounds and percent, and then we're printing out the pounds. Okay? So GCC. Now let's run it. Segmentation fault. What happened here? Did I provide a command line argument? Here's the example I gave you before with 7 command line arguments. There's the executable file, space, first argument, space, second argument, space, third, etc., etc. Did I provide any arguments here at all? Nope. So let's provide an argument. 10.5. How many pounds is that? 23 point something. Right? 100 pounds is going to be 220 something. Okay. All right, but going back to what I did before, no arguments is a segmentation fault. What the heck is that? We'll understand that later on when we talk about memory. Memory is broken up into segments or pages or whatever you want to call them. And an attempt by one program to access memory that doesn't belong to it, the operating system says no way in hell. Why? Because that is a security issue. What if you could write a program that could arbitrarily read any memory in the computer, including, say, SSL, security tickets, passwords, right? And it could also change whatever's in that memory. You don't want that to happen. And so when the operating system sees a program that's misbehaving and attempting to access memory that doesn't belong to it, it kills it as a segmentation fault. You faulted out of your own segment of memory, so I'm going to go ahead and kill the program. And that's what happened in this case because I tried to access an argument that was not provided. So here is a preview of what we're going to do starting next time. A condition. If the number of arguments is not what I expect, if the number of arguments is not 2, why am I expecting 2? A.out is always going to be there, and then the actual user provided argument. If it's not equal to 2, what we'll do is we'll print an error message. Usage is provide a numerical input. There we go. And here's another trick. You can exit out of the program immediately, right? If they didn't provide me any input at this point, is there any hope of creating output at this point? No. So it's fatal. I'm just going to go ahead and exit. I don't want to do anything more, right? Call this properly next time, please. Thank you. And now when I don't provide a command line argument, it says so. It says what the problem is. And when I do provide a command line argument, it's okay with that. What would happen if I provided, say, 4 command line arguments? Remember, the first one is always provided for you. Right? Then 10, 20, 30. Is 4 equal to 2? Nope. So this will also error out. Right? I did provide a numerical input. Okay. Provide a single numerical input. Right? You need to have sensible error messages for users that are not technically inclined, right? All right, but that's human-computer interaction kind of stuff, HCI stuff. What is the proper error message to give to somebody to get them to behave correctly with your program? Right? Here's another way that you can screw up the program. Oh, you want a numerical input 10? What's going to happen here? What happened when we tried to do this with scanf? T. Oh, that's not a number I've ever heard of. So what have I scanned so far? Nothing. What's the numerical value of nothing? 0. Right. Good? Bad? I don't know. Right? You'll have to write a more sophisticated logic in order to get the user to behave even better. Right? What about, say, -10? Can you have -10 pounds, -10 kilograms? Doesn't make much sense, but the conversion program is simply happy with it. So how could we deal with this now? Add another if statement. After we've converted, sorry. After converting, if kilograms is less than 0, then we'll print out a similar error message up here. Right? Error, negative weight is not possible. Right? I guess you could have a negative relative weight, just like you can't have negative pressure, right? Pressure is always 0 to positive, except that you can have negative relative pressure, high pressure or low pressure, right? From one point of view, it is negative pressure because high pressure wants to equalize, right? But that's just a point of view. So if we want our program to not handle that kind of stuff and issue an error message like this, then we need to add in that extra logic. That's what we'll start covering on Wednesday. Any questions? Okay, then you have more than enough to get started on Lab 2, and Hack 2 if you want to early, but of course we're not expecting you to do it get started until Friday. All right, have a good Tuesday.